We are going to be discussing about designing a scalable application with microservice architecture. So let's get started. We have the table of contents as well as the overview. The first one going to look at the introduction and understanding the microservices. What are the main parts of the microservices and how can you design the microservice system? What are the problems with microservices? I will move to the conclusion and open the space for questions. So let's get started. The first one is the introduction. The overview of microservices architecture. So from the word microservice is a way of designing application by breaking them into smaller independent service that communicate with each other. For example, we have a big application we want to design. Definitely this application we are going to split them into chunk into something small and then we take it one after the other. So the word microservice came from something breaking a complex thing into small parts. So what is the word of Martin Fowler on this microservice? He is a software development thought leader. So he said the microservices enable the ability to deploy independent services, making scaling and updates much more manageable. So let's go on and understand microservices. So what are microservices in actuality? So microservices are small, independent applications that work together to form a large system. Each of these microservices has their own logic. Each of these microservices has their own database, a standalone database which is independent, and API. They have their own API. So it allows teams to develop and deploy them separately. We look at the example as we move on. So before we even move to the example, I use a e-commerce application as an example. Yeah. So e-commerce application has separate services. So we have customer and verification and authorization system to allow the user to log in to access a certain page. And we also have a order that tracks, which indicate the customer's order. So we have these various services in a whole application. So each of these service,
Sorry to interrupt. Ibrahim, please, can you turn on your camera?
should I turn my camera on, then I am afraid that I won't be able to make this presentation. It's because of my computer capability.
All right.
I can't be sharing screen at the same time and turn on my camera every time we start slowing.
All right. Okay, go ahead.
Okay, thanks for understanding. So, what are the key features of microservices? So, the first one is that they are independent. Each service can be updated or replaced without affecting each other. The customer service can be updated without affecting other service, without affecting the authentication system service. So, and this has their own database, which is the second point. Each service manages its data without interacting with any other external database. The customer service has its own dedicated database, while user authentication and authorization system also has their own database. So if there is a fault with customer database, then this won't affect the user authentication system database, and it won't affect the other database. So the third point here is that lightweight communication. So in order to communicate with other service, it's use API. It's use REST API to communicate with other database. So which means that if any of these services need one of other service, they communicate using API. So the last point here is that scalability. Service can be individually scaled based on demand. So it can be scaled based on demand. Each one of the service or all of the service can be scaled based on demand, and these are the key feature of microservice. The main parts of microservices. So the first one here is API gateway, and this acts as a traffic controller directing user request to the right service. It directs the user request. So this is a main way each service communicate together. So should you take for example a user which is new uh, to your website or to your e-commerce website. So first of all, before they can make any order, they need to log in to have their account registered with you. So what does this does? These components has been collected together to form a big application, which is your e-commerce website. So in order for the request of the user to go to the right endpoint, so it must pass through this API gateway to ensure that the appropriate endpoint is being used for registering the user. So the second one is service discovery. So this helps services locate and communicate with each other. So the third thing we have here is load balancing. This distributes requests across multiple servers to improve performance. So a service, in order to have a big application working perfectly, it's must when you are implementing this approach, which is microservice, you must have at least more than one load balancer. In fact, each service will have its own load balancer. So in order uh, to distribute the request across multiple servers, so that it won't be only one load balancer that is um, managing the incoming request. So the fourth one here is communication. Like I said earlier, this communication is managed by REST, the REST API. And the third part of the microservice is that database per service. Each of the service must have its own database, its own dedicated database. I hope I'm still audible, please. Hello.
Yeah.
All right. Thank you. So database per service. Each oh sorry. Each of the service must have their own database. So how can we design a microservice? So before we move on, microservice is a technology agnostic, which means that the team that is handling the user authentication and authorization system can decide to use Python, while the team that is handling, I'm using an e-commerce website as an example, while the team that is handling the customer, the customer service can decide to use PHP, while the customer that is handling the ordering service can decide to use C Sharp. So this is technology agnostic. It doesn't mean that one program language should be used for all the service. Each team handling the service can decide what language are we going to use. So how can we design a microservice? So the first point we have here is that we, like I said, from the word microservice, is breaking down something into a big, a complex thing into smaller parts. So the first one is we are going to breaking down the application, and one of the best way to divide an application into microservice is using what we call DDD, domain driven design. So we can see here that DDD stands for domain driven design, and it is a method for organizing software based on real world business concepts. So DDD we use it is one of the best way to divide your application into microservices. So, like I'm using as an example, an e-commerce website. So we use DDD to split this complex application into small parts by having customer service being taken care differently, separately, by having ordering service being taken care directly, and as well as the user authentication and authorization system service. So number two is managing data in microservices. So how can we handle this? And what are the concept behind this? Is that the first point here is that each service has its own database. So that's the first main concept here. In order to avoid conflict and dependency between services, so each of the service should have its own database. And the second point here is event sourcing. To save every change as an event, making it easy to track what's happening. So you have to have, when you are applying this approach, each of these service should have something we call event sources. This track changes in each of the database. It tracks the state of the data in the database. I mean, let's use service since we're using service. It tracks the change of the data in your service, in each of the service, to know what is the state of this service and what is the state of the service. Is it active or is it done, or what is it doing? What data we have currently? So the third point here is CQRS, command query responsibility segregation. So this is applicable to database, which says you separate read and write operation, post and get operation for better performance. Post and get operation for better performance, which in most of the cases this is talking about you having a separate database, even under one service, having separate database that's handling post and that is also handling get. And in other cases, also mean uh, data transfer objects. So if this is your first time hearing this, what you use as a post data, I mean, as a post model, we call this model in C sharp. So what is meant by the model is just the properties, and in database they are called column. What are the data? The data that will be input in the database. So those are the properties, and these are the concept. This is the concept of model. So most of the cases we have ID and some necessary data which you need to input. I mean, when you want to save a data in the database, you have some connection between multiple tables. So that is applicable for post when you want to save a data in the database. But why get, you may not you may only need some necessary strings which may differ from what you use as a so what you use to save, what the model used to save data in the database. Maybe only what you need is just the ID and and the name of the user when you're getting, when you're getting the information about the user. But when you I mean, when you add the new data to the database, like user registration, user we have email, then we have maybe provide picture, phone number, and other things like that. But when you're getting, you know that you're only getting ID and the username, which with this is far reaching from what you use to save something in the database. So this is called data transfer objects, and this also prevents something we call overusing. How can I put it? I really forgot. I will remember. It's some form of attack. So number three is ensuring scalability. So horizontal scalability scaling. So instead of upgrading one big server, you add more server to handle the load. So this is how to design a microservice. Instead, you need more than one server. So this is what we call horizontal scaling, and we also have vector scaling. So vector scaling is a situation that you have a big server. which is capable of handling various services. But for the horizontal scaling, it is advisable and it is recommended to, you know, have more than one server instead of upgrading one big server to handle all the loads. I hope I'm still audible. Can you hear me?
Yes.
All right. So the second point here under ensuring scalability is caching. So you store frequently used data in a fast access memory such as Redis. So this Redis is purposefully used to cache some most frequently used data. So the third point here is load balancing to distribute incoming traffic across multiple instead of a service. So this helps your service to be more accessible in a very efficient time. So like with a little downtime or latency, when you have multiple load balancer working across handling the user request. So the auto scaling is the fourth point. You can automatically add or remove service instance based on the traffic demand. So number four, making microservice reliable, such as resilience and fault tolerance. So this is optional and it is also important. So retry number one, retry mechanisms that if one service failed, you retry to try again before reporting to the an error to the server to the user that something is failing. So retry mechanism. And the second one is cycle breaker pattern to stop failing service from being called repeatedly to prevent system overload. So if one of the service is not working as expected or there is a downtime, it's going to be retrying it. So once like five times or you know what you implement or what you integrate as a retry mechanism, but you have a cycle breaker to stop that service as you try but it is not responding, so to prevent system overload. So follow farm mechanism is the last point here. If one service fails, you switch to a backup. Ensure that you have a backup when you are adopting this approach, microservice approach. So this is what the image of CQRS. You can see one database is handling write while other database is handling the read. So command goes here and query to retrieve something from the database, and event sourcing the image here, it tracks the changes between the two databases. So you can see it tracks the states of two databases. So whatever I say here, it tracks changes to know the states of database B and service B. And this service A, which is using database A, we have event sourcing between the two, event store between the two that track the change between them to know the states of each of both of these databases. So the opposite of monolithic is what is known as microservice. The opposite of microservice is what is known as monolithic. This monolithic, as you can see in the drawing, the user interface, the business logic, and the data access layer, they are all depending on one database, as you can see in the picture and the screenshot here. Oh, there is a typo. This should be monolithic. Why this should be microservice architecture? Why I missed the two? So please pardon the mistake. This should be my monolithic. This here, sorry. This here should be monolithic. Why this here should be microservices architecture? So this is what I'm explaining. You see this service which is microservice. This has its own database, and this also has its own database. So each of these services of the service here, they have their own they have their own database. So we're using Netflix as an example. Before Netflix depends on this whole monolithic box and this whole database and server. So you can see all this authentication, although this AI generated. stuff. But I think it's explained the difference between the monolithic and microservice. So this monolithic, you can see this is a central distributing system or server, which distribute the needful resources for each of these service. You can see each of all of these depends on this one big box. But here you can see each of these service like video streaming, user authentication, all the stuff billing, recommendation, all of this has their own database. In fact, and that's it. So the problem with microservice is the first one is that it is more complex. It is more complex. So as we can see here, the Cyan microservice applications is more complex than monolithic. Microservice, we know about its definition, are a set of small services that are developed and deployed independently. So the challenge here lies in designing the microservice. So how are you going to design it? What are the services that's not going to be depending on other service in terms of when you're designing the service? So data inconsistency. So in microservice, each service manage its own data. So the independent data handling leading to duplication. So this you can't, it is inevitable when you are designing microservice. You may have duplicates, uh, in your database. I mean redundancy. One of the databases have what you already have in one of your database. So this leads to duplication. So number three is security. So you know that when you have multiple service, you are more concerned about the security. Is this may be developed not by only a single team. It may be developed by multiple team handling each service. So, is this team is this team adopting the best security measure for designing their service? So this brings a lot about security concern. So the last one is is maintenance. Since you are using different technology and programming language to build a system, so maintaining these services involve managing these various toolkits as well. So this made the maintenance process costly, complex, and overwhelming. So these are the problem, and these are not mainly only the problems we have in microservice. There are other problems like the numbers of people who's going to take up the service. For microservice, you need more people and you know more money as well because you need more server database per service, and this is costly and it is very costly to maintain. To maintain. So in conclusion, we say microservice architecture build scalable, helps to build scalable, flexible, and resilient application. However, it comes with added complexity. It requires good design and choosing the right technology and strong operational practices. So the key takeaway are microservice make it easier to scale, to update, and maintain your application. So each team can decide which service they want to work on. And breaking an application into microservice should be done carefully using DDD, domain driven design. Like we see, we are we we separate our e-commerce into main three parts, although this is only for something small. And the communication, data management, and scalability are key challenges to solve. Yeah. Also, monitoring, security, and automation are essential for smart operation. They are very, very important. So one thing which I remember is that this microservice architecture should be adopted when you are building a very big application. When you are building a small application, please do not do this because it is mainly reserved for a big application. You know, Netflix is a very big company, And we know Google, Twitter, all these are very big company. I mean, they are very big application. So when you should think carefully, is this your application a big application or something small? So do not try to adopt this when you're building a small application. This reserved for big application. So am I still on the call, please? Hello. All right.
Yes.
Okay. Thank you. So is there any question before I go ahead and ask my own, or are there questions?
Yes. So I do have questions. Yeah. So does anybody have questions? Or I can go ahead with mine. If there are no questions, we can simply say no questions. Any question? Okay. So my question is designing a microservice architecture only applicable to C Sharp only? You know, you started with telling us that you are part of the C Sharp team, right? And yeah, so my question now is that the microservice architecture you are telling us about, is it applicable only to C Sharp? Then the follow-up
No.
question for
Okay.
that is, okay, so if it's not only applicable to C Sharp, why do we need it across all technical teams? And when, okay, I think you've answered the when, but you can just re-emphasize it again.
Okay. Like I said during when we come to was it I think main parts of the microservice, I mentioned that this is technology agnostic, which means that each team, I mean, when we have a big application we want to write, we want to design, as a team, we can be, I am a C sharp developer, you are a Python developer, if I'm right, and we have PHP. Yeah. So each team can decide which service to take up, and it is technology agnostic, which means that you can use Python to design your own. I mean, your service. Say, for example, you're handling user authentication and authorization system. You can use this your Python to handle that. Like we are handling customer, we also can use C sharp, and this will be deployed independently. All these are going to be deployed independently. So, can you still hear me?
Yeah, sure.
So after we deploy it, then whoever wants to work, then we can continue working on the application by calling each of our service which we have deployed. Then we can be using it, developing our application gradually as we have the result that we need, since we have all the service in place. So this is technology agnostic.
Okay. All right. So the DDD you told us about is particular to C Sharp, right?
No, it's not. No, it's not particular. Is method is the best way to. This is just telling you the best way that you need to separate breaking down your application into chunk. This is only what DDD is trying to tell you. You should have a design in place, then before you move on, design writing the code for each of the service before each team can take up their service. We should have something that is, like customer. Customer. We know that this customer, and it is for whoever is visiting our application. This for customer itself. So we should name our service something. Yeah, that's what it is trying to tell you. We should have something named. Like, I hope that you understand that.
Yes, yes.
Uh-huh.
Okay. So that's fine. Yeah, you can just go ahead to ask the questions.
So the first question is method of organizing software based on real world business is known as A microservice. take note of the word method of organizing software. So B, DDD, which is domain driven design. C, business segregation. Can someone quickly answer the question? So
B.
yeah, B, correct. Domain driven design. So you organize your software based on the real world business. So number two, one of the following is a challenge with microservice. A is very expensive. B is resilient. C, technology agnostic.
B. Resilience.
I mean, the challenge, we're having the challenge here, the problem with microservice.
I think that would be B.
I think it's A, expensive.
Correct. Thank you. It's very expensive to,
Wow.
B is resilience because each of these service, they, there are some mechanism like a try mechanism. And when something is not responding, you have a circuit breaker which stop that service from overloading the system. So it's resilience. But A should be the correct answer that is quite expensive to achieve, to maintain. No, in the problem we're having, if I go back a bit, you can see to maintain is very expensive to maintain and it is more complex. How would that clear the misunderstanding?
Yes, I have a question.
Oh, yeah, you can go ahead, please.
So, my question is for the services to communicate, and the communication only happen by consuming APIs. Is that the only way these
No,
different services
no,
communicate?
that's the simplest way. We have something called RabbitMQ, although this a third is another tool, which if we want to talk about it, it's quite, you know. So, but that's also one of the way of consuming your service. But it is a tool. It's called RabbitMQ. But RESTful is the most simplest way, and yeah, is the most simple way which we all understand. Just send a request to the endpoint, and we have that endpoint handling the request. And if not, it's return like 404 or whatever you handle in your API. Does that answer the question?
Yes, it does. Thank you.
All right. So
Okay.
this is the end of the presentation. Thank you for listening.
Yeah, thank you so much, Ibrahim. Thank you everyone that contributed, answered questions, asked questions. So that was very useful. Thank you everyone. Do have a productive day. Katie Alexander.